Welcome, Shadab.
Um, Hi, ma'am. Good morning.
Morning, good evening.
How are you, ma'am?
Getting better. So thanks intense in your busy schedule you have taken time.
No worries.
Let's start the session. I'll just give the introduction.
Sure.
So I wholeheartedly welcome you all for this sixth day of faculty development program conducted by AACT ATAL, sponsored, organized by Mahalakshmi Tech Campus, Krompet, Chennai. So I'm very, very happy to introduce our guest speaker today, Mr. Shadab Hussain. He is a global technology leader at the forefront of artificial intelligence, blockchain, and quantum computing. As a lead engineer at Mathco, he spearheads innovations in engineering and generative AI, delivering transformative solutions that shape the future of enterprise technology. He is a co founder of Quantum Computing India and previously served as a developer advocate at the London Stock Exchange Group, where he bridged advanced engineering with real world application across global developer ecosystems. Recognized as a Google developer expert for AI/ML and an AWS community builder, Shadab also holds certifications in AWS machine learning specialty and Google Cloud machine learning engineer. A TEDx speaker and active contributor to the Davos Digital Council, Shadab operates at the intersection of emerging technologies, policy, and innovation strategy. As accomplished author and researcher, Shadab is a co-author of a book, Quantum Computing in Finance, merging academic insight with practical execution. Through ongoing mentorship, technical workshops, and hackathon leadership, he plays a vital role in addressing the global AI and quantum talent gap and advancing the responsible deployment of frontier technologies. So proud of you, Shadab, and we are very fortunate to have you in our FDP. So please take over the session.
Yeah, thanks a lot, ma'am. Really pleasure to be here and part of this. Ma'am, can I just take 2 minutes? Like I ordered the food and I think it has just come and he's waiting
Sure,
at the
Shadab, take your time.
downstairs.
Take your
It
time.
seems he's not able to come.
Please take your
But
time.
I'll be
Yeah.
just back in
Have
5 minutes
food and
max,
then
ma'am.
you
Okay.
can continue. You can have food and then continue.
Uh, yeah, thanks, ma'am. I will just receive and be back.
You take 10-15 minutes because we are still expecting the participants to join. We'll wait for you. Participants, please wait. The speaker will be joining soon.
Ma'am, I'm here. We can wait for 5 more minutes and then we can start if you say.
No, you need not. You can start at your own convenient time. You
Okay,
can
ma'am.
start.
Okay. Yeah.
Yeah.
Okay, ma'am.
Can you turn on your video and check if you can share your screen?
Yes, ma'am. Just 2 minutes. Ma'am, I hope my screen is visible, right?
Yes, it is visible.
Okay, perfect. I'll just turn on my camera and get started. Sorry, my my camera is on. The screen is visible. Let me just get started. Yeah, sorry for all the delays. I just ordered the food. I was expecting that it will arrive early, but it took some time. So, good morning, everyone, and I'm excited to share uh, with you some of the groundbreaking intersection of two revolutionary technologies, quantum computing and cancer detection. I thought I should keep the session first just pure on quantum machine learning, but then I thought like if we can sort of cover up some of the use cases also of the industries, like what people have been working on, just to touch base and present some of the results that will be like more connecting for everyone. So, as the name suggests, we can see we are calling this journey qubits to cures because we are literally taking the smallest units of quantum information and using them to potentially save lives. Okay. Uh, Usha ma'am has already given my introduction. Um, I will briefly talk about myself. I've been in the industry from like last 9 years approx now. Worked on different domains in different roles. I started my career as a data scientist, then developer advocate, data engineering, ML ops. Uh, like that's how my journey has been so far. And in 2019, actually, I was introduced to quantum computing by one of the IBM meetup in Bangalore. And that year itself, we founded Quantum Computing India community with the aim of like bringing all the people from diverse background and mindset to be part of the same community with the same interest, so that we can explore quantum computing and we can see where all it can be applied in different domains and for different use cases. And that was back in 2019 when there were not much people in India like talking a lot about quantum. Like it was still limited to like academia and premier institutes like IIC, IITs, and all. And since then, like it has been 6 years of journey continuing in the quantum computing space, and we have done we have tried doing some good work in India and globally, like by evangelizing about quantum, hosting offline or online meetups. We organized a couple of hackathons, like as part of Quantum Computing India, like it's still the team sort of like they go and deliver trainings programs for different colleges or even for like Indian Navy. There are a couple of community projects we have been working on. So like if anyone is interested in getting involved in any of the research projects or something where we can be of help, um, like you're always welcome to connect. So let me start with a question that keeps many of us up at night. What if we could detect cancer before symptoms even appear? And what if we could catch it at stage when treatment success rates are at absolute highest, right? And this is not science fiction anymore. This is the sort of like promise of AI and what we are anticipating with the help of quantum machine learning also in healthcare. Because a lot of time, like if you see people are not able to get diagnosed timely, because of which their treatment is not possible. If we can detect the cancer, any kind of cancer at the very early stage, still it is curable. People can get treated and we can save a lot of lives. So, starting with this question, that's the core question. And here's the hard truth that every minute counts in cancer detection. And the difference between early and late diagnosis can literally be the difference between life and death. And the earlier we can catch it, the better the outcomes. But the challenging part is like early detection requires very high precision and the ability to spot patterns that are often invisible to traditional methods. So often, like we have seen, like a lot of AI algorithms and everything exists, but still we are not able to detect the cancers timely, because of which it gets the matter of like life and death for someone. And this brings us to sort of like the biggest challenges in today's world. Our current detection methods, like they are good, but they at times like miss subtle patterns that could that could indicate early stage cancer. And these microscopic changes, these tiny anomalies in tissue structure, they are there, but they are very difficult to be detected even by the AI algorithms at times. I mean, we scientists have been working on, and now we have like much better AI uh, deep learning algorithms, which people are like developing, and it is even getting proved by the healthcare agencies following all the compliances and everything. But still, there's a need of something more powerful, something that can see what we are currently missing. Okay. And if we put this in perspective with some like stats from like this year, we are looking at like over 2 million here. If you look on this, we over 2 million new cases in the US alone this year we have seen. And from brain tumors specifically, we are seeing about like 93,000 Americans diagnosed, and with a 5-year survival rate of 35.7%. And breast cancer, if we talk about 1 in 8 women, that is like around 30.1% will be diagnosed with like invasive breast cancer in their lifetime. And these are not just numbers, these are like mothers, daughters, sisters, friends. Each of these stats represents a human life, a family affected. And this is why the work in the healthcare really matters a lot, like in comparison to like any other industry. So why can't we just use sort of like a powerful classical computers to solve this, right? So classical computing has taken us like way further than AI. Training time is very longer, and it can take sort of like days also to train the data set is very huge. And third is the lack of data. We don't always have available medical images to train the robust model. Maybe there are a lot of like open data sets already being available by different have been already available by different organizations. But at times, like even though we like train a deep learning model or machine learning model so that it can work best, and we try to generalize it, when we try to test it on the new data with some different kind of source data coming from, we end up like with more error rates in comparison to getting the cancer spotted very accurately over there. And fourth one is like poor robustness. These models can be like fragile when faced with like slightly different data or noise, right? So if there are small changes also in the pattern of the data, if some noise gets introduced to the data, then it won't be predicting the right outcome. So these are not like sort of like very small problems. They are very fundamental limitations of classical AI. So that's why this is where quantum computing enters the picture. You may be thinking like quantum computing is still theoretical. We have not proven any sort of uh, that kind of use cases using quantum machine learning or something which are in the production. But even though like we have use cases like using quantum machine learning very efficiently, because there's a lot of like compliance and guardrails we have to go through to make sure that whatever models are getting built is accurate and is not going to be sort of like predicting some random outcome. But scientists, researchers, developers, they have been working together in terms of coming up with better and better algorithms, which can sort of like help us in getting remarkable results for specific applications like medical imaging or the other use cases in different other domains as well, if we talk about. So I ask computers which means then segment where computing because uh, enhance machine learning tasks. You can think of it like giving our AI models. We sort of like try to combine quantum mechanics advanced people have been
Excuse me, Shadab. Is there any internet difficulty? The voice is breaking.
learning. It is, that the, uh, the actual
Shadab, am I audible? Shadab? He will be back soon.
அட்மிட் குடுக்கலாமா? மைக்.
Speaker will be joining soon. Due to some technical difficulty, it takes some time. Please stay back. Speaker will be joining soon.
Hi, man. Can you hear me?
Yes, we can hear you.
Okay, finally. I'm so sorry for the technical challenges we're going through. I didn't expect this, going to be like this bad internet. Uh, are the slides visible, ma'am, now?
Yes, visible. Please go ahead.
Sure, ma'am. Okay, so yeah, I was on this slide, mainly right quantum machine learning part. So let me, yeah. So we have seen how the intersection of quantum machine learning, computer science, maths, it comes together to create this the quantum machine learning side. So if we talk about the if you have to understand the potential of quantum machine learning, so like it's not there yet where exactly it needs to be, or it can immediately beat the traditional machine learning on classical data. So when we say classical data, the data that was generated by classical properties, classical processes, right? But here's what it gets interesting. Like the data sets that are like hard for classical models, but natural for quantum models, those do exist. And medical imaging with its complex patterns and high dimensional data might be one of those sweeter spots. So that's why, like, if you sort of like try to solve like complex image problem use cases and all, we are getting there. Some of the papers and researchers have published some sort of like algorithms and results also, which where they have shown that in what terms the quantum machine learning algorithm is able to outbeat the classical machine learning process. Okay, so yeah, if we talk about quantum machine learning unique properties, then we are talking about the unity of nature, mathematics, computing at the quantum level. And there's this the non-deterministic state of like quantum systems, superposition and entanglement, and the exponential size of quantum state space as well. So all of this sort of like translates into potential applications across healthcare, finance, material science, and many other domains. So the quantum layer adds a dimension of computation that simply doesn't exist in classical systems. So here is a visual comparison. On the left, you can see traditional neural network layers of interconnected nodes processing information sequentially. And on the right, you are seeing quantum neural network, which is using quantum circuit gates operating on qubits. And the quantum approach can explore multiple computational paths simultaneously. So it's not just a faster classical computer, it is fundamentally different way of processing the information. So that's why like when you're working with hybrid quantum machine learning approaches and all, we try to sort of like first convert the classical data to quantum data, and then we can make use of quantum processing over there. So this is our first research project which we worked on. So we developed a hybrid classical quantum model for MRI-based brain tumor classification. And we combined transfer learning from ResNet 50 with quantum neural networks. And this paper we published in IEEE. So you can go and check it out. You can scan the QR code if you want to read the paper and the results and the approach what we followed over there. We achieved sort of like some remarkable results that I will be sharing in the upcoming slides. But the QR code, like if you scan it, it will take you to that technical details and implementation, like whatever we did. So in this paper, how we approached it, we started with the BRA-TS dataset. It has like thousands of MRI scans. And in the classical computing phase, we pre-processed the images, extracted features using ResNet 50, And then we mapped those classical weights to quantum weights. Then in the quantum computing phase, we constructed a quantum neural network and performed both binary classification, like tumors versus no tumor. And we also performed multi-class classification, identifying sort of like a specific type of tumor. We then compared everything against purely classical models to see like what outcome or results we're able to achieve. So these are the results of like binary classification. On the left, you can see the training and validation accuracy. We were able to achieve like stable performance. In the middle, our confusion metrics sort of like shows excellent separation between tumor and non-tumor cases. Like there are certain false negative there, but the numbers are very less. And on the right, that shows the ROC curve. It was having the AUC of 0.96, which tells that the model is excellent discriminative, like it is having excellent discriminative ability. It was able to predict the outcome with much more reliability, you can say, in this case. And if we talk about if we go in detail, sort of like looking at different metrics like precision, recall, F1 score, and support, you can see like we were able to achieve 96% overall accuracy, 98% precision for tumor detection, and the recall rate was like 95%. And these are not just good numbers, these are sort of like clinically relevant numbers that would make a real difference in patient outcomes. And if we talk about like multi-class classification, where we are not just detecting tumors, but trying to identify specific types, there also we were able to achieve 89% accuracy. You can see from the confusion metrics that most prediction fall on the diagonal, which is exactly what we want. And this is the detailed metrics which shows weighted average accuracy of like 89%, with some classes performing even better. And class 2, for instance, no tumor cases, we got 100% precision and recall. That's the perfect identification what we are trying to achieve. Um, and this is our second research project where we tried using quantum transfer learning for breast cancer detection. Given that, like we have seen in the previous slide stats, like 1 in 8 women will face the diagnosis. So improving detection accuracy even slightly can save thousands of lives. So this research was also published by IEEE. We worked with mammographic images, which present their own unique challenges. They are noisy, subtle, and require sort of like very high precision to interpret the like outcome from those images very correctly. So if anyone of you are interested, you can just scan the paper, or you can even search by the paper title and the author names. You will find it. So in this, we used the Breakins data set with like around 10,000 mammographic images, half cancers, half not. And our hybrid approach combined ResNet 50 feature extraction with a 4-qubit quantum neural network. Like we use very basic quantum neural network just to test the approach. Obviously, like if you scale it to the more number of qubits, you can like bring in more features, which will result in more accuracy of the results. So here is what made this study particularly interesting. We tested performance at different data availability levels as well. When we are using 100% of the data, when we are using 75% of the data, or 50% of the data, or just even 25% of the data. This is crucial because in real world scenarios, we don't always have massive data sets, right? So if we have the scarcity of the data, how well these models are going to perform, that also we try to test, go with our hypothesis and try to test it in this paper. So if you look at the results were quite impressive. Our quantum transfer learning model achieved 95% accuracy approx compared to sort of like 92% which we observed in classical CNN. So there was 2.6 percentage point, like 2.6 percentage improvement. And if you look at the other like other metrics, so we have seen 3.3%
Program application and it acts as a
All participants, please mute your mic.
Can we mute, ma'am?
Yeah, yeah, we have done it. You can continue.
Okay, sure, ma'am. Yeah. So in the other metrics also, we saw like sensitivity or it was improved a bit, lower false positive and false negative rates. And in medical diagnosis, as we talked about, like these differences translates directly to saving the lives, right? Also, like we didn't just try to measure the impact of quantum processing in terms of like the accuracy and the other model metrics, but also we tried evaluating the results in terms of like computational efficiency as well. So our quantum model converged in just 25 epochs versus like 40 epochs it went for classical CNN. Training time was also reduced by nearly 69%, and memory usage dropped by 33%. Energy consumption was cut in half, and we had better like inferencing speed, like time to analyze a single image was 40% faster. And what really excited us was the performance with limited data. So at 75% of the data, we maintained 94% accuracy approx. And at just 25% of the data, we still achieved accuracy of around 89%. That is like 7% higher than the classical CNN. So this robustness with limited data is huge for resource-constrained healthcare settings where we don't have enough data and all. We can make use of quantum algorithms to train or build a robust model. So where do we go from here? Like the future of quantum machine learning in healthcare is like very exciting. These are just two of the use cases which I talked about. There are a lot of use cases which can be tapped in. Like there are like enough. Like if we just talk about different kind of like medical images for different kind of diseases, we have like a number of use cases in the healthcare domain itself, which can be solved with much precision, even if we have the scarcity of the data. And we can prove certain like efficiency and accuracy and also certain computational efficiency by using the hybrid approach over there. So if there are three sort of like main directions. First is like we can focus on error-corrected quantum computing as quantum hardware is improving and qubits are becoming more stable. We'll be able to build more complex, more accurate models. Second one is like scaling up to larger qubit counts means richer feature space and ability to detect like even more nuanced patterns. So like in my previous paper, as you saw, I just we just used like 4 qubit circuit. If you scale that system to like 50 qubit or 100 plus qubits, definitely will see more better results out of the algorithms what you're going to design. And third one is like integrating quantum computing with Gen AI opens up possibilities for multimodal healthcare applications, and we're just beginning to sort of like imagine those areas. So these are some of the quantum machine learning algorithms and some of the challenges we face. So the field is rapidly evolving. We have quantum neural networks, quantum SVMs, quantum clustering algorithms, quantum transformers, also like companies like Quantium and all, they have been working on that. And the list goes on. But we also face real challenges like loading training data efficiently, implementing non-linear activations in quantum systems, avoiding barren plateau in optimization, how we are going to deal with noise in current quantum hardware. And these are not like just uh, like which can be just solved easily. They require continued research and innovation. Then we have privacy, security, ethics concerns as well. So like this, perhaps you can see like how, I mean, the presentation title was not just a catchy phrase, it's a sort of like call for interdisciplinary collaboration. We need quantum physicists who understand the hardware, clinicians who understand the medical context, and data scientists who can bridge both worlds. No single discipline can do this alone, and this is fundamentally a team sport, right? So how people from academia with like who are quantum physicists or quantum scientists, how we can sort of like collaborate with doctors, how we can bring in someone with data science and machine learning expertise to make this real, what we should be looking at. This slide we have, I have presented in a couple of like previous talks as well. Like what are the other areas where quantum computing can be applied? So like it goes far beyond than healthcare. Like you can uh, make use of this in aerospace industry, finance, logistics, drug discovery, and many more. There are a lot of like companies and research innovations around the world which are like heavily invested in quantum technologies. And advancement is like going at a very fast pace these days. And these are like a couple of quantum companies. I know like I have covered some of the topics and the papers and all. So if you want to get the slide, this is the QR code. You can keep the screenshot of this, or you can just scan it and it will take you to the Canva link of the presentation. Anyway, I'll be sharing the presentation link with ma'am also, so you will get it handy. And if anyone wants to get in touch, these are my social media and like my contact and email ID. You can just drop me an email. And other thing like this was just the theoretical aspects and the results and the paper what we have done so far. If anyone of you want to get started with quantum machine learning, then PennyLane is like one of the very commonly used library which we use for quantum machine learning. Most of our work for our work also either we are using Qiskit quantum machine learning library or PennyLane library. But we have like PyTorch quantum version as well if you want to use that. So it's up to you, like which packages and all you want to use. And PyTorch also, you can see we have certain examples on the pages over here. You can just run these code and you can sort of like create and design your own circuit. You can choose the like quantum backend of your choice because it has the integration with the Qiskit and different other backends like I need to check. And you can see the results and outcome like what you're getting out of it. So this is like these are the couple of the resources which you can go through like Pennylen quantum machine learning, Qiskit machine learning, and then the PyTorch version. And also like if I talk about some of the use cases and the call for proposal invites and all that. So there is this Cleveland Clinic quantum computer CFP. So if you go over here, you can see they have recently launched this quantum innovation catalyzer program. They are like inviting ideas for the healthcare. I mean, unfortunately, okay, yesterday was the last date. I'm a bit late in sharing this with you all. But in US, if you see all, they are inviting the companies and researchers to, I mean, if you have some ideas, if you want to build companies and all, you can apply to these kind of like programs to like make your ideas real. So this is one of the company. Then we have another launch pad like QAI Quantum Launchpad. Like it was pinned up in Canada. They have recently expanded to Asian Asia region as well. They have presence in Switzerland also. So they run a lot of like boot camps where they start with sort of like identifying the good ideas and then guiding the founders to build their own startups. So this is another sort of like uh, which you can follow. Then we have Qubit Ventures. They recently, if you are into the hardware domain and all, like I don't know how many of you know Qubit Ventures. This is founded by Nardo, like he is an investor. Uh, and recently he announced sort of like a photonic, I think, photonics launchpad. Yes. So if you have any ideas sort of like related to photonics and all, you can always sort of like go and apply and be part of such competitions. And you can see like the funding and all is like very huge if you sort of like are able to showcase the actual value and outbid the other teams. So unfortunately, like this competition is also over. Like this is not live, but these kind of competitions sort of like you can think of like where the industry is moving and how fast it is moving. So Qubit Venture I talked about. One more was there. I'm forgetting its name actually. Apart from like these just quantum focused like launch pads or fundings, we have started seeing the interest from other domain investors also uh, now all the investors and big tech companies have been coming together to invest into the quantum startups. So recently, NVIDIA and Google recently announced some supremacy, and something was from the yeah NVIDIA NVQ link. Actually, I want to talk about. So they are coming up with sort of like new sort of like QPUs where you can sort of like you can see it is a high-speed interconnect lets quantum processors connect to the world-leading super computing labs. So that's where they're heading now, like with NVIDIA partnership. Google also announced recently some supremacy, a couple of, I mean, 1 or 2 weeks back or a couple of days back, I think. So there's a lot happening in the industry. It's up to us, like how, what domain, what area we want to focus on, and how we want to like make best use of all these things. So I will stop over here. I know, like, sorry for the like hiccups, whatever I had to go through during the session because of my internet connectivity. I'm open to questions. If we have any questions, you can just unmute yourself and ask, or you can ping that in the chat. And there
Participants
are like
can
a couple
make
of
use of this opportunity. Please ask your doubts. Yes, sir. Please go ahead.
different days. Like this conference also happening in like Spain, which is on QAI. Let me actually open this post from here. Yep. So we'll find a lot of like good conferences happening globally. So as someone who is very close to academia and research, right, you have the opportunity to lead this as at the forefront and contribute to sort of like your area of expertise and your area of interest wherever you want to contribute. So this conference is happening in like March in Spain, and they have the CFPs open. The last deadline is like December 17th. Like I'm planning to submit one paper for this conference. Similarly, like you can also plan it out and submit some of your papers or some of your work if you get ready by then. So yeah, qaio.org you can go to for the paper for the conference. So these kind of like whatever I am aware of, like I'm able to share with you, but there's a lot happening beyond this as well. So you can just Google search and find more resources. In India also, like I remember one call for like if you need some support with patent and all, the government is supporting with it. If you need support with like if you want to exhibit your AI related work in India AI Summit, which is going to happen in next year in February, it's a very good platform to showcase your work during that as well. So you can submit your proposal on this website, impact.ai.gov.in. So try to leverage the local ecosystem in India. Like there's a lot happening. You can see like all the key participants coming in this conference. So this is also like a very big opportunity. Like if some of the papers gets accepted, or if you want to apply for any of the challenges. So this is research symposium where like you can submit your papers and work. So I think that's it from my side. I will stop over here. I'm like open to questions if anyone is having. I will share some of the links, like whatever I can in the chat. This one has already expired. Okay, Usha ma'am, it doesn't seem anyone is having any questions.
Yes, Shadab,
So
and
I have a
yes.
question. Can I just go forward?
Yes, sir, please.
Yeah. So thank you so much for your very resourceful talk. I just have a small question. What would be your suggestion as to suppose what would be the immediate demonstrable power of quantum computing, which you can suggest to my students to begin with, because they are new actually. So to
Mhm.
make them more confident on quantum computing, what is the small demonstrable project that I can give? What can be your suggestions, please?
So it should be you're looking for quantum machine learning, sir, or in generic
Quantum
for
machine learning,
quantum
sir,
computing?
because these days students are more into machine learning, and we have
Mm,
got a number of departments working on specialized machine learnings also. So
mm.
quantum QML would be quite good. Yeah.
Yep. So for QML, maybe you can ask them to sort of like go through like these basic tutorials first. We have good YouTube playlist also like
Mm.
available,
Okay.
which will help them in understanding the basic sort of like first, like how exactly they can, what are the different concepts and nuances in that, then different algorithms, how they can use. So
Okay.
once if the basic is strong, then they can sort of like start implementing and making use of any real-time data. So
Okay.
the outcome, how the student should look at is like they can pick the data set of their choice. There are like a lot of data open through data.gov.in or even through Kaggle, they can find data from for different use cases.
Yeah.
But if they don't understand the basics of like how exactly they should be sort of like designing those circuits, what's the optimization function they're going to use, right? Or activation function they're going to use, how the quantum data they're going to create, how well they can optimize the circuit. First, they need to test that on simulator before running that on the actual quantum computer. So those things will help them in giving more confidence. And then if they switch towards like implementing some of the projects alongside, that will be easier for them to sort of like uh, work on some of the use cases. But they can just start with very basic use cases rather than sort of like going with very complex sort of like data set or very large data set, which itself can take a lot of time just to solve the data problem and all.
Right, sir. Okay. Thank you so much.
Okay. Yep.
Thank you. Thank you so
I
much.
mean, it's a very vague answer, I know, but I mean, somewhere they just have to start and develop the interest over the period of time. So this is the basic which they need to be aware of. This was the 2021 QuizKit summer school, QuizKit Global Summer School. And if you look at the playlist, right, so they have covered like starting from the basics to the algorithms to the like advanced implementations. Yeah. So Baron plateau issue and all what I was talking about. They have like explained everything in detail with like hands-on examples and notebook. So since then, there has been a change in the implementation, how the Qiskit was back then and now. Like it has all most of the functionality and packages have been like decoupled from one another. But still, it will help them in understanding the basics, and then like Qiskit machine learning, they can always refer to these pages.
Sure, sir. Thank you so much. Thank you.
Thanks, sir. Uh,
Any more questions?
any other?
Shadab, I think right from first year or from the school itself, if the students can focus more on physics and maths with the basic foundation, I think they can do well in quantum. What do you think?
Yes, definitely, ma'am. Understanding the like as in the field of data science, we have certain prerequisites to understand probability and stats and linear algebra. same for quantum computing also, we have certain prerequisites. And the curriculum which has been designed by Department of Science and Technology in India, it is very well structured. And I think they have already started offering minors degree program in quantum computing. So if they are good with the basics, and then if they jump to the quantum machine learning, then that will be like more, they will be able to do it more, or else it will be like just shooting the arrow blindly if they don't go through the basics.
Okay. So thank you so much for your wonderful time. Can I know your time now? What's the time now?
I'm very happy to present to you today the basic concepts of quantum
I'm just trying
computing.
to play your.
In the 2 hours, we will talk.
Oops, sorry. Some noise was coming. I think
Nothing,
it was from
nothing. I
my
was
side.
just clicking your
Okay.
link. I
No
was
worries.
clicking your YouTube link, no, from the chat. Okay.
Okay. Okay, ma'am.
What's the time now there?
Ma'am, it's about to be 12:30 now. 12:25 it is right now. Yep.
Okay, so thank you so much for your time, and I hope all our participants would have got inspired first of all with the energy what you have at 12:30 midnight, and
Yeah. Thanks, ma'am.
the knowledge what you have, and I should wholeheartedly thank Durai Karthi sir first of all for connecting us with you, and he is also a wonderful person with so much of knowledge, and
Yes, definitely, ma'am. He's a
yeah,
mentor and inspiration to me as well. He always come as a rescue for me if I'm stuck anywhere.
Durai
So
Karthi
KG
sir,
sir
are
is
you
actually
online? Durai Karthi sir, if you're there, you can turn
I
on the mic.
I think I can't why I can't see him. He may not
You
be
can't
here, I
see him.
think.
He may not be there. Okay. So thank you so much and for your time. And I'm pretty sure you're not well, but still you've taken a lot of time uh, to share your knowledge. And God bless you. And see you soon in India in the next week
Ah,
in
definitely,
Chennai.
ma'am. I'm looking forward to
Meet
it.
you, meet
Yes,
you, meet you in person. Yes.
yes.
So thank you so
Thanks,
much,
ma'am.
and thank you to all the participants. And this is the final session of our FDP, and went on successfully. Thank you so much. Thank you so much.
Yeah, thanks a lot, ma'am, for the
Yes,
invite, and
Shadab.
thanks
Thank
to you
you.
all
Please,
for
please.
joining.
Yeah. Please. Thank you.